just pass it back up. Everybody sign in? Okay, so today we're going to talk about two subjects. The first one is graphs of linear inequalities. Thank you. So, you know how to graph a line. Now, a linear inequality is basically a line that instead of an equal sign, it has a greater than or equal sign, or a greater than sign, or the less than versions of that. So I want to talk about how to graph that. Then after we finish that, we'll get into functions and domains and ranges and things like that. So it's going to be two widely different subjects today. But anyway, we'll start out with graphs of linear inequalities. So we've dealt with inequalities before with one variable, but now we're going to talk about graphs in two variables, x and y. So it can take any of these forms. Now this is a little bit different than the standard form, where we had that ax plus bx plus c equals 0. These are lowercase, and notice that the c is on the other side of the inequality. And this, you'll find, is going to be a very handy way to graph. Now you can also have equations that look more like y equals mx plus b. So you could have y is greater than mx plus b, and you'll handle them the same way. But for now, this is going to be the primary form that I'll be using. All right, so if we go back to what a solution is, that's an ordered pair that makes the inequality true. Okay, when we have a line, there's infinitely many points that solve that line, right? There's anywhere along the line. But we have something a little different with an inequality. If we just take an inequality here, and I'm going to choose a point, 1, 3. So if I substitute this in here, I get 3 times 1 minus 2 times 3 is 3 minus 6, and I get negative 3 is less than 4. That's true. Okay, so 1, 3 is a solution. If I look at 1, 4, so this has the same x value but just a different y value, I plug this in and I find that 3 minus 8 is negative 5, which is less than 4, so both of these work. Neither of them, though, are actually on the line. So if we say, if this was equal, neither of these 2 points would be on that line. So these are solutions, but they don't happen to reside on the line that's similar to that would be the line of the equality. So we're going to have many solutions, but not only solutions that are related to each other, but we're going to have essentially not a line, but a half of a plane worth of solutions, because these areas are going to be essentially the whole plane divided in half. So let's look at what happens. Let's take y equals 2x plus 1. And so you know how to graph this. Easy way here is just to take the intercept of y equals 1, and then we go over 1 up 2, and we do that both ways, and we get this line. So anything along this line will be a solution to that equation. So if I kind of eyeball this and I see that negative 1 and negative 1 is a solution, if I put 2 times negative 1, I'll get negative 2 plus 1 is negative 1. So that indeed is a solution. So I have any x has exactly one y that goes along with it. Now, if I take something that's similar, y is less than or equal to 2x plus 1. What I'm going to find, though, is if I put this line in here, that any point along here will be a solution. And in fact, every point that's on this side of the line will be on the solution. So if I just take 5, 0, so x equals 5, y equals 0. So if I have 2 times 5 is 10 plus 11, plus 1 is 11, we do have 0 is less than or equal to 11. So we have essentially this whole half plane. So what we want to do in order to make these graphs, and we want to make the line, because that's definitely the boundary of something, we're going to essentially indicate which half of the plane is part of the solution and which part isn't. So the first thing that you're going to do is, if you have a strict inequality, meaning that the equal sign is not present in there, you're going to use a dashed line, because that's only going to represent a boundary. It doesn't represent any part of the solution. But if we have a greater than or equal to or a less than or equal to, that equality part says that the line, if we just take away the inequality, we still have the equals part, that line will be part of the solution. So we're going to use a solid line when it's like this, a dashed line when it's like this, the strict inequality. So let's take our example and look how we're going to graph this. So the first thing I'm going to do, this is less than or equal to, so we're going to draw this as a solid line. Then the next thing we're going to do is we're going to choose a point to test. Now, it's true that any point, if one point on this side of the line works, all of the points. And if one point on this side works, then all of them work. If one point doesn't work, then none of them work. Okay, so the planes are really divided in half. One of the easiest points to test will be 0, 0, right? It's easy to calculate with 0. So let's put in a 0, 0 here and see what we get. 2 times 0 is 0 plus 1. So we have 0 is less than or equal to 1. And that, of course, is true. So if it's true, then I want to shade this whole side. Now, in a book, or if you have a colored marker or something like that, you can color it in. Now, if this is false, if it turns out that 0 is greater than 1, which is false, then you would shade the other side. So you just go ahead and you shade it. Now, with a pencil, this is kind of hard to do. I don't want you to color in the whole side of the page with a pencil. I'll show you on the next graph. You could just use lines at some interval to indicate which side is on the graph. Okay, so here's another example. Let's say we want to sketch a graph of x plus 2y is greater than 2. So we're going to graph this with a dashed line because we have the inequality. But I still am interested in the line because it'll form the boundary. So we're going to draw this line, but with a dash. Now, graphing this is fairly straightforward when it's in this form, right? We can find both of the intercepts. We can find the y-intercept by setting x to 0, and so 2y equals 2. So we know 0, 1 is one of the intercepts. And then if y equals 0, the x-intercept is x equals 2. Okay, so we have 2, 0, and 0, 1 and 2, 0 are our 2 points, and so we can put them on the graph, and then we make the dashed line. Okay? So now the next step is we're going to test, and 0 is clearly on one side of the line, or you know, it's away from the line. If it was exactly on the line, we have to choose a different point. But if it's away from the line, you use that, and we'll stick in a 0 there, and we put it in here. We test 0, 0, and we get 0 is greater than 2. That's false. This is the false side, so this is the true side. And just indicate with lines like this which side is the true side. Now, most of you are not going to take Math 3, which is finite math, a math that's oriented towards business. They do something in there for what's called linear programming, where they take multiple areas and they're trying to find the intersection of several areas. And they will tell you to do it the opposite, that you shade all the false pieces, and then what remains unshaded is true. So recognize that sometimes textbooks will tell you to shade the false side. I'm going to tell you to shade the true side. Okay, so, and I think that's the way most calculus-based tracks go. Most calculus textbooks will show the shaded side as the true side. Okay? Okay, so it's time for you to try. There's actually 4 here. And what I'd like to do is I'll let you get started on this. I'm going to choose some people to, we'll do 1 here, 2 there, 3 over there, and then 4 over there. So go ahead and get started, and if I call you to do one, 3 or 4, you can just jump right to that. And then when you're ready with the one that you have to put up, just go ahead and put it up.